Number 5 says f of x equals sine of x over x. And they want to know, find f prime of x, that's the first part, and the second part, find f prime of c, and c happens to be here pi over 3. When I have a fraction, I don't like to call it f of x, so I'll probably change this to y, because when I have a fraction, I call the top of the fraction f, I call the bottom g. So I don't want you to get confused. So I'm going to take the f of x out and just call it y. And I'm looking for y sub prime instead of f prime. You know, it's the same thing. So that's what I'm going to do. And again, the reason I switched, I took the f of x out and put y, because you know when I have a fraction like this one, quotient, I'm going to use the quotient rule. I always call the top f of x, and I call the bottom g sub x. The derivative of this, because you're going to need them, might as well do them right now instead of wasting time later. What's the derivative of sine? Cosine. And what is the derivative of x? That's a 1. And if you remember, the quotient rule says if you want to find the derivative, it's the bottom times the derivative of the top minus the top times the derivative of the bottom. All of that divided by the bottom squared. Notice in the bottom, not the derivative, just g sub x squared. And now if I fill in the blank, I have all the pieces there. If I just go through and fill in all the pieces that I have, I should be in good shape. X times f prime, which is cosine of x, minus sine of x times what? Isn't that a 1? Over g sub x, which is x squared. So that's the answer to part A. I just don't need the 1. I'm not going to put the 1 there. So when the question says, what is f prime? The answer is x cosine of x minus the sine of x over x squared. Part B, what's the derivative when x equals pi over 3? That means you got to replace x with pi over 3. Divided by pi over 3 squared. And now I have to go to the unit circle. And if you don't have one with you, just go to Google and write unit circle. If you didn't memorize the values. And if you hit enter, and you got a stack of them. Here we go. Pi over 3. The cosine is 1/2. So this is pi over 3 times a half minus the sine of pi over 3, which is the square root of 3 over 2. The whole thing divided by, when you square this one, that's pi squared over 9. The easiest way to clean this, you multiply the big fraction, the top and the bottom, by 9. If you multiply by 9, you'll have in the bottom pi squared here. 3, that probably will give me, I could factor the 1/2 out of each one. Notice that I'll have a division by 2. If I take the 1/2, what is 9 times pi over 3? That's 3 pi minus, the 1/2 is gone, 9 the square root of 3 in this case. So I could leave it like that. Or if I don't like the 1/2, just put a 2 in the bottom. Because I see a 2 and a 2, I just factor that out. So I can leave it like this. And again, if you don't like the 1/2 in the front, I have no idea how they want the answer. It could be 3 pi minus 9 the square root of 3 over 2 pi squared. Like that. And that'll be fine too. Just going by gut feeling. Really, I have no idea what they want. They're probably looking for that answer. Just gut feeling. I might be wrong, but no reason. I just think that's probably what they're going to look for. They might even factor a 3 out, make it 3 over 2, because you can take a 3 out of each one. Notice if you take a 3 out, what's left here? Pi minus 3 the square root of 3. Because a lot of books, they like to simplify completely over 2 pi squared. And if they don't like the 2, they might make it 3/2 in the front. Either way. I mean, I can put 10,000 different answers, and they're all saying the same thing. Which one they want, couldn't tell you. If you've done the homework, you probably know which one. But I don't know which way they want the answer. This is good. This is good. This is good. If they want to factor, that's good. Any one of them. Okay, that was 5. You know what? Let me put the answer and see which way they want it. Which one should I try? Which one you want to try? Should I try the last one I wrote here? Yeah. Let's see if they'll take it. Fraction. Another fraction on the top. 3 over 2. Parentheses, what do I have there? Pi minus, I got to insert pi without symbols. Pi, yep. Minus 3 times the square root of 3. Functions is it? Where is it? Yeah, the square root. Do they have one just says square root, straight square root? Oh, they do have it, yep. So let me take the one I took out there. 3 times the square root of, what was it, 3? The whole thing divided by, we said, what was it? Pi squared? Where's symbol? Pi. And how would I square it? Is there, yep, square. And the other one, I'll leave the other one out. I don't really care about if I got it wrong or not. I can put it there quickly. I don't want to waste time putting the answers here. Oh no, I didn't get out of that box. I'm still in the bottom box. There we go. X cosine x. For cosine, just do you write cosine or they have a built-in one?
They have one in the trig menu, but you could write it in as well.
You can write it in?
Yep.
So the trig cosine of x what was it? Minus the sine of x minus the sine of x, and in the bottom divided by, we said what, x squared? X to the power of 2. Submit. Submit. Nope, I got them both right. So I put that answer and took it. Now curious what would happen if I did this or this. But I put that one and they took it.
I took it and I didn't even like simplify or factor.
You left it like this? Pi over 6 minus the square root of 3 over 2?
I like
9?
Mine was I didn't factor on the top, like
Yep.
factor it out. I just left it.
Like 3 over square 3 halves pi minus 9 over 2 square root of 3 over pi squared.
My 2 is on the bottom though.
Oh, you put the 2 in the bottom?
Yeah.
Okay. So you left it like this.
Yeah.
Yep. So it looks like it took this, it took that.
I'm pretty sure I went all the way down to decimal and it took it.
You did decimal too and took it?
Yeah,
Really?
I believe so.
Wow. Some of the software, when they're looking for the exact answer, they're really picky. Let me see 6 versus 8 quickly. Okay. 6 is I have y. They call it f of x. I'm going to call it y here. I'm not going to type the answer anymore because that takes a long time for me to type it. I'm wasting time here, especially when the camera is running. And they want to find the derivative and the derivative also at 0. They want both of them. When they give you 0, it's always nice because 0 is like you plug it in straightforward. Again, you let f of x is the top, which is sine of x. The derivative of that is what? Isn't that cosine of x? G sub x is the bottom, which is e to the x. The derivative of e to the x is what? Hopefully you memorize it by now. What's the derivative of e to the x? E to the x, good. And y sub prime is going to be g times f prime. G times f prime minus f times g sub prime, all divided by g squared. Plug in the values. G is e to the x times f prime, which is what? Cosine of x, minus f of x, which is sine of x, times g sub prime, which is e to the x, the whole thing divided by what? E to the x squared. Now, when you look at the top, notice they have e to the x is common, right? So if you factor that out, what's left? Cosine of x minus sine of x. In the bottom, you have e to the x squared, which means what? E to the x times e to the x. And what do you notice about the e to the x here? They cancel each other out. You'll end up with what? Cosine of x minus the sine of x over e to the x. So that's part A. This is as a function of x. Part B, it says what's the derivative at 0. I forgot I changed this to y instead of say what's f here. I already changed it to y. So what is y sub prime of x? What's y sub prime of 0? So what is y sub prime of 0? You let x be 0. Cosine of 0 minus the sine of 0 over e to the 0. Cosine of 0 is 1. Sine of 0 is 0. E to the 0 is 1. The answer is 1. Are we good with this one? Okay. I was about to skip 8, but I like 8 actually. You have f of x, that's number 8, equals what? X minus 5 over the square root of x. Bless you. Now I know you probably want to use the quotient rule. And that's fine. But there's a quicker way than the quotient rule. Much, much quicker. When you look at that, this is x minus 5 over what? X to what power? 1/2. And if you bring that x to the 1/2 to the top, becomes what? X to the minus 1/2 times x minus 5. So multiply it through, distribute that. What's x to the minus 1/2 times x? When you multiply, you add your exponent. What is minus 1/2 plus 1? That's 1/2. So all I did, I'm just playing with the algebra to rewrite that problem. Because now if I want to find the derivative of that, for this is going to be 1/2, move the power to the front, and subtract 1 from the power. What is 1/2 minus 1? Minus 1/2. The next one is going to be, what is negative 5 times a minus 1/2? Negative 5 times a negative 1/2. Plus 5 over 2. X, subtract 1 from the power. Minus 1/2 minus 1, that's negative 1/2 or 3/2. Did they allow you to write the answer with negative exponents? They do? Oh, good. That makes life easy. So you can leave it like this if you want to, or if you want to divide it by 2, you can write x to the negative 1/2 plus 5x to the negative 3/2. The whole thing divided by 2 instead of 1/2 times that. But they're saying it doesn't matter. They allow you to write the answer like this. So if that's the case, type that one in, and there's your answer.
What would the rule be for moving both those negative exponents to the bottom? Would it be over 2?
If you decide to bring the negative exponent to the bottom, this, actually looking at this one, this will be 1/2, right? And this will be 1 over x to the 1/2. And what is x to the 1/2? That's the square root of x, Nico. Plus, this will be 5 over 1/2. That's a negative exponent, 1 over. This is x to the 3/2. Well, isn't that x times x to the 1/2? Because when you multiply, you add your exponent. That's what a 3/2 is. So this is 1 over 2 the square root of x plus 5 over 2 times 1 over, this is x, and the other one the square root of x. So if you really want to clean it, 1 over and if you want to be like a math major, go, well, wait a minute, I'm adding fractions. If I'm adding fraction, what do I need? Yep, which is what? You need to multiply this by x to make them match, right? So if you multiply this by x, you got to multiply that by x. So that becomes, in the bottom, 2x, the square root of x. X times 1 is x, plus the 5. And if they say, wait a minute, you're supposed to rationalize. If you're a math major, say, this is not good. Then you multiply the top and the bottom by what? Square root of x, right? So if they want to rationalize, now we're getting carried away with it, but because they don't want to see a square root in the bottom. So you end up with, in the bottom, 2 times x squared, because the square root of x times the square root of x will give you another x. And in the top is going to be the square root of x. You can leave it like this or distribute that. It won't make a difference. But they're probably happy with this answer. We just decided to have more fun with it. We added some fireworks to it. And it's the 4th of July. Let's go in style with it.
Could you not move them down to the denominator in the second answer there, like x to the negative 1/2 plus 5x to the negative 3/2? Could you just move that down?
Move what down?
Okay, on your secondary answer, right after where you
Box here?
The red box, right to the right of that, my right, your left.
Yep.
Yeah. Could you move those ones down?
You got to make them separate fractions. No, you can't. You can't move this down, this one down. It has to be individual ones.
All right.
That was 8. As I said, we get carried away with it. Find the derivative sine t over t. We just did that. That's sine x over x. Number 11. That was number 5, by the way. So I'll skip 11. And after 11 comes 15 on my list here. We have y equals, that's 15, y equals 3e to the x over x squared plus 9. Again, that's a quotient here. The quotient rule would be the way to do it. The top is always f of x. And what's the derivative of that? It's 3 times the derivative e to the x. What's the derivative e to the x? E to the x. And what is g sub x?
X squared plus 9.
And what's the derivative of that?
2x.
Again, I've probably done about 500-600 of these problems. You'll see me every time I do it, I still write the definition. G sub x times f prime of x minus f of x times g sub prime of x, all divided by g squared. And once you have these 4 pieces, really just nothing more than fill in the blank. That's why I like to do these first. Because when I get to this point, I don't want to be distracted. I don't want to have to go back, oh, what's the derivative of f? It's already done for me. I get f, it's derivative. I get g, it's derivative. So when I get to this point, I get all 4 pieces in my hand. Just got to fill them in. What's g sub x? X squared plus 9. What is f prime? 3e to the x. Minus. What is f of x? 3e to the x. What's the derivative of g there? That's 2x. All divided by what? X squared plus 9, the whole thing squared. And again, they probably leave it like this. Or you could distribute that. If you distribute this, so you could distribute that or leave the first part alone. I'm not sure if they'll break it down or they'll leave it alone. And the last one will be minus what? 6x e to the x. Me personally, I would probably factor 3e to the x.
Yeah, I pulled out.
Because if you factor 3e to the x,
Yeah, that works.
what's left? X squared minus the 2x plus the 9. And the reason I wanted to pull that out, I'll tell you why I wanted to pull it out. Because I was thinking maybe I could factor this, and who knows, maybe something will cancel the bottom. But I can't really factor that one. In some cases, you might be able to factor this and maybe cancel one of these. It ends up being matching one of these. So you want to try to factor them out, see if anything will help me here. And no luck here. So x squared minus the 2x plus the 9. I just put them in order. Not much. That's as far probably as I can go with it. Almost all of them is the quotient rule. One minus cosine theta.
Who did the section 3 on 16.
Use a computer algebra system. Differentiate the function.
I think that's put in a damn calculator.
I don't know if they want you to use like some software or not.
Yeah, that's
I'll do it by hand.
use me.
Because the question, what's the derivative? So
Oh, okay.
I really don't pay attention to what they're saying use. I'm going to do it by hand. So you let f equals f of theta, we're not using x here, sine theta. The derivative of that is cosine theta. Let the bottom equals 1 minus cosine theta. And the derivative of 1 is 0. There's the minus. What's the derivative of cosine? Negative sine. So a minus negative sine is going to make it what? A positive sine theta. Derivative of 1 is 0 minus a negative sign. Minus a negative sign makes a plus sign. You don't need the 0 in the front. You want to put a 0 plus that, that's fine. Still sine theta. So now the derivative here again, g times f prime minus f times g sub prime, all divided by g sub theta squared. And g is what? 1 minus cosine theta. F prime, what is f prime? Cosine theta. Minus f of theta, which is what? Sine theta. Times g sub prime, which is also what? Sine theta. Over g, which is 1 minus cosine theta squared. I already see something will simplify here. Is the answer 0 for that one? I think it might be 0. If you distribute that, what do you have? 1 minus cosine squared theta minus sine squared theta.
There's a different amount.
Huh?
No, I thought we had the same one for a
Nope.
second.
I can factor a minus out of these two. Notice if I take a minus, what's left there? Sine squared theta plus cosine. Doesn't really matter which one you write first, cosine or sine.
Or you factor the minus too.
From here and there, these two. See them? You have a minus common. Now, why did I factor the minus?
You can just pull the minus out of the cosine squared minus sine squared.
Sure, why not?
Why wouldn't it make the 1 plus sine squared?
It's a minus this. When you distribute that, you better give me this.
Okay.
So let's make it minus sine squared minus cosine squared, which is what you have right here. Now, why did I pull the minus sign out?
Sine squared plus cos is equal to 1.
Yep, sine squared plus cosine squared equals 1. Rule 7. So that's rule number 7. So it will be 1 minus 1 over 1 minus cosine theta squared. And what's 1 minus 1? 0 divided by anything. What's the answer? 0.
Why wouldn't you distribute the cosine theta to 1 minus?
Oh yeah, it's cosine. I'm sorry. There's cosine here. Yep.
Yeah.
Yep. I meant it, but I didn't do it. It's the 3rd of July. I guess I'm getting excited here.
Just 0 in each.
Yep, cosine times that. Thank you.
I entered 0 answer and it gave me wrong.
Yep, it's wrong.
But
So,
it's my last chance.
but this is actually, see, I'm tricking you. Don't listen to me. Cosine theta minus 1. Look at the bottom now. It's 1 minus what? cosine theta times what? 1 minus cosine theta. Make sure you keep your eyes open. I make mistakes all the time. I'm not a professional. Do these guys cancel each other out? Can I cancel these two? What do you think?
No.
You're right. Well, you have right. You have right, half wrong.
You have to pull out a minus sign.
You got to pull a minus sign out because they're backward. So you end up with minus 1 over 1 minus cosine theta. And what they might do, like me personally, I don't like the minus on the top. I can bring it to the bottom. When you have a fraction, the minus could be anywhere. So I could write that 1 over cosine theta minus the 1. I got to move it there a little bit. 1 over cosine theta minus 1. Yeah, you got to distribute this, and I guess I fell asleep there when I did that. I missed that one. Because I was excited about this. Like, oh, that's cosine square plus sine square. Uh-oh. Uh-oh. No. You know there's 1 out of 14. I missed it. You know how I feel about putting them in order. I missed the 14.
Your OCD's going to go crazy.
Yep. I just realized, like, no. I like things done in order, but I guess I should have had my coffee today. The 2 is really a constant in the front, so if you don't want to pay attention to it, that's fine. Just plug it at the end. But if you want to leave it as part of this, that's fine too. Now we have a product. We have 2e to the x times cosine of x. So we have to use the product rule. Here's f of x. And there's g sub x. The derivative of f is what? The 2 is a constant. Don't worry about it. What's the derivative of e to the x? E to the x. Cosine. What's the derivative of the cosine? Isn't that negative sine of x? Now we have a multiplication. That's the product rule. The derivative as a function of x, it's f times g sub prime plus, not a minus, plus g times f prime. F times g sub prime plus g times f prime. Plug in the values. What's f? 2e to the x times a negative sine of x plus cosine of x times 2e to the x. Notice 2e to the x is common to both of them, so I'll put that first. And my OCD said you should write the cosine first because I don't like to see the negative first. I'm going to put this one first, this one second. I don't like to start with the negative. Two e to the x times cosine of x minus sine of x. Couple more, then we're done with this section. I got 17 and 20.
19-2, please.
I'll take a look and see. G, I'm not going to use, they're using F, I don't want to use F, I don't want to use G because I use them, so we'll call it H of X or Y, whatever you want to call it. Cosine X, secant X, and the question is, find H prime of 6, when X is 6. We have a multiplication. We have cosine times secant. So it's the product rule. F is the first, the cosine of X. F prime is what? What's the root of cosine? Negative sine of X. It says use graph and utility to verify your result. So that means use calculators basically, because your answer is going to be crazy decimal values. G sub X. G is what? Secant X. What's the derivative of secant? Supposed to memorize these. What's the derivative of secant? Very good. Secant X, tangent X. You really want to memorize these because we're going to be adding to them today. Product rule again. The first F times G sub prime plus G times F prime. Cosine of X, G sub prime, which is what? Secant X, tangent X, plus G sub X, which is what? Secant X times F prime, which is what? Negative sine of X. Now you know your calculator doesn't have a secant on it. So if we take the secant, replace it by its value, secant is what? Isn't that 1 over cosine? And if I simplify the first part, what will happen to the cosine? Cancel each other out, so what do you have? Tangent X plus the secant is what? 1 over cosine of X times the sine of X, or minus actually. So this will be plus what? Negative sine of X over cosine of X. Wait a minute, what is sine over cosine? Negative tangent. What's tangent X minus tangent X? So what's the derivative at 6? Still 0. Yes?
Could you go at the top and see that cosine X times secant X simplifies to 1, and 1 would be a flat line, so the tangent line.
Cosine. Oh yeah. Yep. I didn't even notice that. Good. Good. Yep. Actually, yep. Good job. He said if you simplify that problem, I just jumped to the product rule. But notice, if you just took a look at that problem, you say, let me simplify it first. Maybe I could simplify it. And you can eliminate about 10 steps. You can eliminate all of these steps. 17, again, part B, step method 2. Here we go, cosine of X times the secant. Secant is what? 1 over cosine of X. So what's going to happen here? What's the function equal to? 1. What's the derivative of 1? 0. Is that easier? What's the derivative of 0 at 0? Is it 6 or 0? Is it 6? Still 0. Either way. Sometimes I did it what my GPS does. Sometimes I put the GPS to go to New York or to go to Washington, D.C. When I get to New York, it takes me off the highway. I go through Manhattan. I spend about an hour and a half driving through Manhattan. Then it puts me back on 91. Why? I have no idea. But it gets me there. And that's what I did with mine. I got off 91. I'm going through Manhattan now, zigzagging there. Oh, yep, there's my answer, back to Washington, D.C. This one straight through the highway. No traffic, nothing. So sometimes when you keep your eyes open or if you simplify the problem, you can really make it a lot easier. There's a good example of that. Oh, 19 is the second derivative. I'll call it y equals x over x minus 7. And the question, what is the second derivative of x? That means I need to find the first derivative. And after I get that, take the derivative of that to get the second derivative. And guess what? When you find the first derivative, you better simplify it here. Because if you don't, it's going to make the math 10 times worse. So let's look at the first derivative. What's f prime of x? 1. G sub x is what? X minus 7. What's the derivative of that? Still 1. The first derivative I'm talking about is going to be g times f prime minus f times g sub prime, all divided by g squared. G, which is what? X minus 7 times f prime, which is 1, minus f, which is x times the derivative of g, which is 1, all divided by g squared, which is what? X minus 7 squared. And if you clean that, what do you have? Isn't that negative 7, if my eyes are good, on the top, over x minus 7 squared. Now I'm going to take the second derivative. I'm going to cheat here. Instead of making this f and this is g and repeat the process, we covered section, what was it, 4? Notice if you look at that through section 4, this is negative 7, x minus 7 to what power? Negative 2. What's the derivative of that? You multiply this times that, becomes positive 14. X minus 7 to what power? Negative 3 times the derivative, what's on the inside? What is the derivative of x minus 7?
X.
Try again. 1. So it's 14 over x minus 7 cubed. Notice a lot quicker if you know that method. We covered that last time.
It's a chain rule, right?
Well, the chain rule, it's called this extended power rule, or the general power rule. But it's really the result of the chain rule, yes. So that's the quicker way. I was about to do the quotient rule. In this section, though, I want to do the quotient rule one more time. I'm going, hey, forget it. I already covered that method. I'm cheating here. I'm jumping to that shortcut. Find the second derivative, the last one, which is number 20. I don't know why I put a space between secant and x, that much space. It's not secant times, but secant of x. The first derivative, what's the derivative of secant? Isn't that secant tangent? Now I'm going to take the derivative of this. You have multiplication, that's secant x times tangent x. So we have to use what method? The product rule. Or what rule there? The product rule. f of x equals the secant, you have a multiplication. The derivative of that is what? Secant x tangent x. G sub x is the second one, which is tangent x. And what's the derivative of that? Derivative of tangent is what? Isn't that secant squared x? So again, the second derivative now, because that's the derivative of this, is going to be f times g sub prime plus g times f prime. And by the way, if I multiplied these guys together, what would you have? Sine over cosine square, right? So if you want, you could use the quotient rule. If you multiply these guys, you'll have sine square over cosine square. So if you don't like the product rule, you can use the quotient rule, because you have a fraction. And it will give you the same answer. F times g sub prime, what's f? Secant x, what's g sub prime? Secant squared x plus g, which is what? Tangent x times the derivative of f prime, which is what? Secant x tangent x. Notice you have three secants. You have secant and tangent squared. So here we have secant cube x plus secant x tangent squared x. So you can factor secant out. And what's left? Secant squared x plus tangent squared x. You can look on the board, see if you have any trig identity that have secant squared plus tangent. I don't have it. I have secant squared minus tangent. That's number 9. If I take the tangent squared to the right side, it becomes secant squared minus tangent squared equals 1. That's a plus, unfortunately. If that was a minus, that would be perfect, because that would have been a 1 times the secant, which is secant.